Our lesson about conic sections is parabola. At the end of this lesson, the students are expected to be able to first, derive an equation for a parabola whose vertex is not at the origin. Second, define the axis and the latus rectum of a parabola. And third, give an equation for a parabola whose vertex is not at the origin, given some of its parts and features. Before considering parabolas whose vertex is not at the origin, let's review and make sure you have gained mastery of parabolas with vertex at the origin. By completing this table, the first equation, y squared equals negative 12x, has negative 3p, focus at negative 3, 0, and the equation of the directrix is x equals 3. The second equation, 1/4 x squared minus y equals 0, has p equal to 1, focus at 0, 1, and the equation for the directrix is y equals negative 1. And for the last equation, negative x squared equals negative 8y, p is 2, focus is at 0, 2, and an equation for the directrix is y equals negative 2. Recall that the curve defined by the equation y equals f of x minus h is just the curve defined by y equals f of x, but translated by h units horizontally. In particular, the translation is to the right if h is greater than 0, and it is to the left if h is less than 0. On the other hand, if we translate by k units vertically, the equation for the translated curve is y minus k equals f of x. If k is greater than 0, the translation is upward, and if k is less than 0, the translation is downward. All that is left to do is to note that a parabola whose vertex is at hk is translated h units horizontally to the right if h is greater than 0 and to the left if h is less than 0, and k units vertically upward if k is greater than 0 and downward if k is less than 0. Let's study the following theorems. An equation for a parabola that opens up or down, whose vertex is at hk, and whose focus and directrix are absolute value of 2p units apart, is the quantity x minus h squared equals 4p times y minus k. The parabola opens up if and only if p is greater than 0, while the parabola opens down if and only if p is less than 0. An equation for a parabola that opens to the left or to the right, whose vertex is at hk, and whose focus and directrix are absolute value of 2p units apart, is the quantity y minus k squared equals 4p times the quantity x minus h. The parabola opens to the right if and only if p is greater than 0, while the parabola opens to the left if and only if p is less than 0. Let's take a look at the following examples. Find an equation for a parabola whose focus is at 2, negative 2, and whose vertex is 2, 4. Mentally visualizing the given will help you conclude that the parabola opens downward. Since the distance between the focus and the vertex is 6 units, p is equal to negative 6. Finally, since the vertex is at 2, 4, the equation for the parabola is the quantity x minus 2 squared equals negative 24 times y minus 4. Example number 2. Find the focus, vertex, and directrix of the parabola quantity y plus 3 squared all over negative 12 equals x minus 1. For the correct identification of p, we rewrite the equation in the standard form y plus 3 squared equals negative 12 times x minus 1. Thus, 4p equals negative 12, so that p is equal to negative 3. Next, we identify the orientation of the parabola. Since the second degree variable is y, And since P is negative, this is a parabola that opens to the left. This means that the focus is to the left of the vertex and the directrix is a vertical line to the right of the vertex. The vertex 1, negative 3, is 3 units away from both the focus and the directrix. Therefore, since the focus is on the same horizontal line with the vertex and is to the left of the vertex, the focus is at negative 2, 3. And an equation for the directrix is x equals 4. Let's have some definitions. The line through the focus and the vertex of a parabola is called the axis of the parabola. Note that the axis of parabola is in fact a line of symmetry, so that it is sometimes called the axis of symmetry of the parabola. Note also that the axis of a parabola is always perpendicular to its directrix. The chord through the focus that is perpendicular to the axis of a parabola is called the latus rectum of the parabola. The length of the latus rectum is related to the distance between the focus and the directrix. You may pause this video to answer the following exercises. This exercise is for level 2 students only. This exercise is for level 1 students only. This exercise is for both level 1s and level 2s. But for level 2, you should also answer letter D. Check your answers if you got it correctly. Thank you.